Convert each of the complex numbers given in exercises 3 to 8 in the polar form. Now we are supposed to convert this in the polar form. A polar form is similar to finding the, let us say, modulus and argument. Yes, it is similar to finding the modulus and argument. How do we convert in the polar form? Let's talk about any complex number in general. For any complex number z equal to x plus I y, we can write it in the polar form. The polar form looks like r times cos theta plus I sin theta. This is what it looks like, right? So how do we convert this in this particular form? You can clearly observe that x is simply equal to r cos theta. The real part is equal to the real part and the imaginary part is equal to the imaginary part if this is equal to this. What do x, y and r theta represent? Let me draw the diagram once and explain it for you. For any point P, x comma y in the argand plane, x plus iy can be represented by this point in the argand plane. This is the real axis and this is the imaginary axis. Real axis and imaginary axis. Now this point P can also be represented in another way. What we do is, we draw an angle theta first and mark a point at a distance r on this line, right? On this ray at an angle theta, you mark a distance of r and therefore you reach P. So this P can also be represented by this r comma theta. This P can also be represented by this r comma theta. And yes, you can observe from here. What do you observe from here? Can you please observe that? Let's drop this perpendicular and r cos theta. This is r cos theta. This is r sin theta. Okay. This is the base and this is the perpendicular. This is the cos component. This is the sin component. That's what you know, right? So this length is r cos theta. This length is r sin theta, which is also equal to, this length is also equal to this x. This is equal to x and this is equal to y. That's what I've written over there, right? And with the help of this, you can further find the values of x and y. The value of r can be found easily, as you can clearly observe. If we square and add, square this and add them together, what you get is r square cos square theta plus r square sin square theta. R square will come out common. Cos square theta plus sin square theta is simply 1, which gives me r is equal to under root of x square plus y square. Okay, you could have taken a minus also there, but traditionally, or as you can say, this is the distance and we consider only the positive value over here. So this is r is equal to under root of x square plus y square. This is also known as the modulus of z. Okay. And what else? What about the argument? Argument can also be found from here with the help of, depending upon the location of point P, yes, and we have seen that depending upon the location of point P, we can find the argument very easily. Cos theta and sin theta can be found with the help of x and r. Once we find r, and on the basis of that, we can easily find theta. So keeping this in mind, let us focus on finding the polar form of this particular complex number 1 minus I. So let z equals 1 minus I. Okay. Therefore, what will x be equal to? X is equal to r cos theta, y is equal to r sin theta. That is something which we know. Is equal to x plus I y. Let this is equal to x plus I y. Okay. Therefore, x equals 1, y equals minus 1. And we can easily find the value of r, which is equal to under root of x square plus y square. R is simply equal to under root of x square plus y square, which is under root of 1 plus 1, which is under root of 2. So you have found the value of r over here very easily. Okay. Also, we know that x equals r cos theta. Since x equals r cos theta, this implies that cos theta becomes equal to x over r. What is that? 1 by root 2. And y is equal to r sin theta implies sine theta is equal to y over r, which is minus 1 by root 2. You can observe that cos theta is positive, sine theta is negative. Which quadrant are we talking about over here? Can you observe that the quadrant in which the complex number lies can be noted from there directly or from here as well. Cos theta positive and sine theta negative. So you're actually talking about the fourth quadrant over here, right? You're actually talking about the fourth quadrant over here, and the angle alpha can be easily found over here. The angle alpha, or finally you want theta actually. Theta is minus alpha, you know that, right? You remember theta is minus alpha, and tan alpha is simply equal to, can you observe, tan alpha is tuck tuck tuck, this is 1, this is also 1, tan alpha is 1 over 1, implies alpha is pi by 4. Alpha is simply pi by 4, or you can further note that therefore theta is simply minus alpha, which is minus pi by 4. Observe, theta is minus pi by 4, right? So this is the argument of z. You have already found the value of r, that is modulus of z, and therefore z in the polar form can be represented as, therefore z in the polar form equals r times cos theta plus I sin theta, which is root 2 times cos minus pi by 4 plus I sin minus pi by 4. This is what I will be representing the value of z as.